Hi guys, this is Miss Kabani from Saxe High School. This video is to help with ideal gas law. We have talked about ideal gases in the sense that they follow kinetic molecular theory and they behave kind of like real gases in the sense that they are at high temperatures and low pressures. So when we're using the ideal gas law, which is not a perfect law, by the way, this has a lot of assumptions to it, but it is an important part of chemistry. So the equation is what you see here, PV equals nRT, where P is pressure, V is volume, N is the number of moles. R is a constant, and I'm going to explain it in a second. And T is temperature. Okay. Just remember you can have several units for pressure. Pressure could be atmospheres, it can be kilopascals, and it can also be millimeters of mercury. Okay, so when you are actually using your R, when you're plugging in your R, you have to look at which unit of pressure you're in, and then that unit of pressure will tell you which R to use. Okay, so for example, if the pressure unit that you're in is atmospheres, you're going to use 0.0821 for your R. If your pressure unit is kilopascals, you're going to use 8.31 for your R. And if your pressure unit is mmHg, millimeters of mercury, you're going to use 62.4 as your R. Okay, so it really depends on which unit of pressure you're in. That's the R that you use. Okay, all of these will cancel out when you plug them into the equation because, you know, when you divide by volume, liters and liters cancel out. The pressure will cancel out, moles, all of this is going to cancel out, and you're going to be left with this number. Okay, so don't pay too much attention to the unit. You know, this is a very odd unit for a lot of students, but all of it does get canceled out. The important thing is that you know that if this is your pressure, this is your R. Okay. Another important thing I need to mention is that temperature has to be in Kelvin, okay? In case you forgot, if you have something in degrees Celsius and you want to get to Kelvin, all you have to do is add 273 to whatever number that is, and you'll get your temperature in Kelvin. Okay, oh, that's right here. So remember to use Kelvin. Temperatures, and volume must be in liters. Okay, if you have something that's in liters, you're good. Keep it in liters. If you see it's in milliliters, okay, well, there's 1,000 mLs in 1 liter. So if you divide by 1,000, okay, you'll get your answer in liters. Okay, so say for example, I have something that's 680 milliliters, and I need to get it to liters. Okay, well, there's 1,000 milliliters in 1 liter. So if you divide by 1,000 or just move the decimal 3 places to the left, you're going to get your answer in liters. Okay, so these problems aren't going to be hard. It's just going to be a lot of things that you have to keep track of. You have to know what unit of pressure you're in. That determines your R. You have to make sure that your temperature is in Kelvin, not degrees Celsius. And another thing you have to look out for is that your volume is in liters, okay? So if we try to trick you and we give you something in milliliters, just remember to divide by 1,000 or move the decimal 3 places to the left and you'll get your answer in liters, okay? So the best way to really show you guys this is to do a few problems, okay? I'm on page 6 of the packet, the gas packet. And it's going to tell you everything. You just have to, again, you just use the equation. Okay, so it says here, what volume, okay, so I'm looking for volume, would be occupied by 0.625 moles of hydrogen. So remember, moles is N. Okay, ATM is pressure, so if I have 4 atmospheres, that is my pressure. and my temperature is 37 degrees Celsius. Remember, we cannot have this in degrees Celsius. We have to add 273 to that. So that will get me 310 Kelvin. Okay, and then now what do I use for R? Okay, well, my unit of pressure is atmospheres. So the R that you're going to use is this guy, 0.0821. Okay, and you just have to look out for the unit of pressure in the measurement here. Okay, so if this is atmospheres, I use this R. Same thing with kilopascals, same thing with millimeters of mercury. Okay, so I'm going to plug it into my equation. I have PV equals nRT. Okay, my pressure is 4. V, I don't know what it is. I'm solving for V. My number of moles is 0.625. My R is going to be 0.0821. And my temperature is 310. Okay, and then now I want to get volume by itself, so we're going to have to divide 4 to each side. Okay, so we're going to do 0.625 times 0.0821 times 310. Okay, and that's 15.9. So to get volume by itself, we're going to divide 4 to each side. Okay, so then these will cancel out. And then 15.9 divided by 4 is 3.97. Okay, we're just going to round that up to 4 liters. Okay, so we just solved for volume. On the next page, you're looking for the number of moles. It says how many moles of gas fill a 2.2 liter vessel. Okay, well, that's my volume is 2.2 liters. My pressure is 915 millimeters of mercury. That is a unit of pressure. Okay, my number of moles, I don't know. That's what I'm solving for. My temperature is 25 degrees Celsius. Again, Celsius is not going to cut it. So we're going to add 273, and that gets me 298 Kelvin. Okay, now notice my unit of pressure is millimeters of mercury. So I'm going to have to use 62.4 as my R. Okay, your gas constants are given to you. So you just have to know which one to use. And again, it's based on your pressure. Okay, so I'm solving for N. Okay, if I have the formula as PV equals nRT, if I want to get N by itself, I just have to divide RT to each side. Okay, so essentially if I do PV over RT, that equals N. Okay, so that's exactly what I'm going to do. I know my pressure is 915. My volume is 2.2. My gas constant is 62.4. And my temperature is 298 Kelvin. Okay, so we're just going to multiply the top, divide by the bottom, and that gets you your number of moles, which is N. So the top is going to be so that gets me 0.11 moles.